Okay, so you have learned a powerful formula, Newton's second law, that will be used in each and every chapter that's going to come from here in physics. F is equal to ma. What does that mean? It means that if a block is of 1 kg and a force of 5 Newton is applied on the block, then you have been asked what is the acceleration of this block if the surface has no friction, it's a perfectly smooth surface. Then you would say F is equal to ma. The force has been given 5, mass has been given as 1. You have been asked acceleration. That is finding. The finding of it is very easy. The acceleration will be 5 meters per second square. So some things, 2 out of the 3 would be given and you have to find a third. Okay. Similarly, suppose there are 2 blocks side by side. One is of 3 kg, other is of 2 kg, and you have a force being applied of 10 Newton on the 3 kg block. Then what would happen? The surface is smooth again. We are not talking about friction yet. So 10 Newton of force is being applied, and you can understand that both of them will move together. Although the force is applied on 10 Newton, but if I ask what would happen, will both the bodies move together or they'll move differently? They'll have different acceleration or they'll have the same acceleration. Of course, since the 3 kg block lies behind the 2 kg block, it will be pushing the 2 kg block. And both will be moving with the same acceleration. They'll be moving as one unit. So the acceleration of whole of the system, although they are 2 different bodies, but they will be moving together, they could be taken as a system with same acceleration. So F is equal to ma. Acceleration from here comes out as 2 meters per second square. Now, there will be some normal reaction. As we have talked before, normal reaction is always there between contacts when 2 bodies presses each other, and this time 3 kg block is going to push 2 kg block. So there is some stress there and there will be some normal reaction build up. So if you have been asked to find out what is the normal reaction acting on this surface. To do that, draw the FBD of the 2 kg block. mg downward, normal reaction from the surface upward, and the normal reaction from 3 kg block towards right. And if you have to look into the horizontal direction, then this mg and n is not going to do anything. So the only force that is going to move this 2 kg block towards right is the normal reaction from this contact. So you write the equation of dynamic this time. Previously, we used to write the equation of static, saying that the net force is equal to 0. This time, net force is not going to be 0 because the body is moving. So use the Newton's second law of motion, equation of the Newton's second law, and say that F is equal to ma. The force on this block is n dash. Mass of this block is 2. Acceleration of this block you have found out as 2. That means the normal reaction got to be 4 Newton. Okay, and you can cross check. If you draw the FBD of 3 kg block, then mg downward, normal reaction from the surface upward, normal reaction from the 2 kg block will be on the other side, n dash, and the force is being applied towards right, 10. So if you have to look at the motion in horizontal direction, the net force towards right is 10 minus n dash. Net force is equal to mass is 3, acceleration 2. So from here, you can see that n dash is coming out as 4, which has to be equal and opposite. Okay, so using FBD of any one of them, writing the equation of motion for any one of them, you can find the normal reaction because it is an equal and opposite pair. The value on both would be the same. Okay. Similarly, there's a block and there's a thread attached to it. There's some tension in that. The block is suppose of 3 kg. The whole system is going upward by 2 meters per second square of acceleration. So how much is the tension? Tension. Write the equation of Newton's second law of motion. T is upward, mg would be downward. Net force is mass into acceleration. So tension got to be 36 Newton. Okay? So that's how you use Newton's second law of motion. So we'll have a little more practice on the same. Let's solve more problems. There's a block kept on an inclined plane. of mass m. The angle of inclination is theta. So what's going to happen if you leave the block just as it is, there is no friction? What's going to happen? The block is going to remain there, it's going to come down, go up. What's going to happen? To know that what's going to happen, draw the FBD. FBD is mg and n. Normal reaction is normal to the surface. Mg is vertically downward. These are the two forces, and this is the inclined plane. So if you look the force along the inclined plane, there is a net force along the inclined plane, because this angle is theta. If you're going to break mg perpendicular to the plane and along the plane, and remember, in this kind of problem, when you have an inclined plane, we always break the components of force along the plane and perpendicular to the plane, because it's in the plane that the motion can happen. We don't break it vertically and horizontally. The body, if at all it comes, it will come downward, or if some force is applied, it will go upward, but the motion will be along the plane. So we always break the force along the plane and perpendicular to the plane. Normal reaction is already perpendicular to the plane, and if we break mg perpendicular to the plane, it will be mg cos theta, and parallel to the plane it would be mg sin theta. Okay, now perpendicular to the plane, if you write the equation of motion, block is not going to go perpendicular to the plane. It was always going to come along the plane. So the net force along perpendicular to the plane should be 0. So from there we get normal reaction should be equal to mg cos theta. Good enough. And the block is going to come down with how much force? This mg sin theta is unbalanced. There is no force opposite to it. So mg sin theta is going to drag the block downwards. So the acceleration downward, this is the net force, mg sin theta. Net force is going to be mass into acceleration. So the acceleration with which the block is going to come down is g sin theta. With this acceleration, the block will move down. Okay? Bolo bachon, okay? You are learning Newton's second law of motion.